going to show you some interesting things you can do with aquabeads. And what are aquabeads? Well, aquabeads are small gelatin beads that absorb 150 times their own weight in water. So this takes about 6 hours, and I have here some aquabeads that have been prepared. They make nice spherical beads, rather like lenses. One of the interesting things I get students to look at is a beaker of water, or what looks like water. Ask the students what's in there. Mostly they'll say they're water. Get someone to stir it. When you stir it, you see suddenly all these beads pop up. And they're always fascinated with that. And why is that? And the reason is that the refractive index of these beads is exactly the same as the refractive index of water. They can be used rather like the lens of the human eye, or a bullseye. And if I hold this up here, and you can see there's quite a lot of beads, but you should be able to see that the writing is magnified because they're spherical in shape. Because they're flexible, the students can play with them individually, squash them onto writing and see that the size of the writing changes. Then moving on, there are other interesting things to do with the beads. One of the things that I do is I soak them in starch solution. So they've been soaked instead of in water in starch solution, and then we can add iodine. And we all know that iodine and starch gives a nice blue-black reaction. So if I just tip out a little bit of that liquid there, and we can see that the beads have gone a nice blue-black. Another thing to do would be to trap an aqua bead perfectly in a test tube like that, trapping a column of air, and then we can put it into hot water and watch that the bead moves up as the air expands inside the tube. So this is expansion of a gas with heat, and then we can, after we've watched the bead move up, we can actually put it into cold water, and that's ice water, and the air contracts and the bead moves down. What the students can do is put little marks on the tube and actually measure the expansion and contraction rates. Another thing to do would be to soak them in universal indicator solution, so we get the nice green neutral colour, and then add a base to one. So I'm going to add base to this one, and just surround them with the sodium hydroxide. And then with this one, I'm going to add some vinegar, which is an acid. And then it takes a little while, but the students can watch the edges of the beads changing colour. These green ones are developing a pink edge, pink-red edge. These ones have developed a purple edge. So another interesting thing would be to put them in hot water to speed up the diffusion of the acid or the base into the beads. An interesting biology experiment that can be done with the aqua beads is to grow a unicellular alga called chlorella on them. Chlorella is obtainable from most biological suppliers. It takes a few weeks for them to grow on the surface, and they end up looking rather green, but now we can do a nice photosynthesis experiment with them. The beads are set up in the dark, covered in foil, until they maintain a fairly high CO2, carbon dioxide output. And then after so many, I say an hour or so, you can take off the foil, light switched on. Now they photosynthesize. And in photosynthesis, then they absorb carbon dioxide, and the carbon dioxide levels drop. So it's an interesting way of demonstrating photosynthesis using the beads to support the algae.